This is a play about photosynthesis. Photo what? Photosynthesis. Photo what? Photosynthesis. So what's that all about? A plant making sugar. A plant making sugar? Yes, so it can grow. Oh, so it can grow. Growing in the roots and growing in the stem and growing bigger branches and growing bigger fruit. Where does this happen? In the chloroplast. Where's the chloroplast? In the cell. Where's the cell? On the leaf. Where's the leaf? On the stem. The stem on a plant. The stem on a plant. A leaf on the stem. A leaf on the stem. The cell in the leaf. The cell in the leaf. The chloroplast in the cell. The chloroplast in the cell. The chloroplast. The chloroplast. The chloroplast.
It's a blast being a chloroplast.
It's a blast being a chloroplast.
It's a blast. Blast.
Blast. Blast.
Being a chloroplast. There's not just one of us, you know. In each cell there's many.
And when we each do our part, we make enough food for the plant. And enough oxygen for all you humans.
You can't see us by looking close at a leaf.
We're too small. Even if you put special glasses on, you still couldn't see us. We're too small. We're itty bitty. Even if you got out a hand magnifying and looked at a leaf, you'd see the surface and it would look cool. But you still couldn't see us. We're very petite.
You'd have to get a high-powered microscope and get that thin slice of wood.
And then you'd be able to see chloroplast in a cell.
And if you did, get that microscope out.
And look at that thin slice of wood. And you see rows and rows of cells. And in each cell, you'd see chloroplast. Happy chloroplast.
Having a blast.
Just being chloroplast.
You might say it's a happening place, because it's a place where stuff's happening.
It's not just blah, blah, blah stuff.
What happens here is important, hugely important, vastly important,
Gigantically, abundantly, colossally.
important
To the plants.
and to everything on the planet Earth that breathes oxygen.
Say that again.
What happens here is hugely, vastly, gigantically, colossally important.
To the plant
And to everything on planet Earth that breathes oxygen.
Hello, how are you today?
I'm a chloroplast, and I live inside this here plant cell. There are many other chloroplasts in the same cell, and they all do writing. Make food for this here plant. Yup, it all happens right here in this tiny space. Now I know some of you are wondering how, so let me show you. I'm fixing to start up a new batch right now anyway. Boys, have a beautiful bright day out. Oh look, here comes some light energy direct from the sun.
It sure is dark.
I wonder what kind of place this is.
Hey, let go.
Gotcha, ha.
What do you mean? Let go.
Nope, I mean, now you leave with me.
What do you mean?
Well, you see, water will be entering the cell any second now.
Water? I entered this place from about 3 feet off the ground. There's no water around.
Well, you see, the water is coming from the roots of this plant, where it is being pulled out of the ground. And some of the roots reach pretty deep to find it.
Okay, so the water is coming.
No, wait, that's not possible. How can the water flow up? Gravity doesn't work that way. Well, you see, it travels in tubes called the xylem. And you're right, normally water doesn't travel up. But in a plant like this, and even in a tree, water is kind of sucked up the way soda is sucked up through a straw. It's called transpiration. Here we are, boys.
Isn't this more water than we need?
Yes, but don't fret. The water that is not needed will evaporate through the surface of the leaf.
So why am I here? Somebody tell me what to do.
Okay, calm down. You need to be patient. We are waiting for one more special guest to arrive. And as soon as everybody's here, we can get this party started.
Exactly what kind of party will it be? I didn't bring a present or anything.
Will you be serving cake and ice cream?
Well, we get to wear party hats.
No, my friend, this is not that kind of party. It's really more like being part of an incredibly important worker. This plant can't go without it.
Say, we feel a draft all of a sudden. Close the window, pal.
There are no windows in a plant cell. Air can pass right through these cell walls, and that area feeling is just what we need now. Well, not all of it, just the carbon dioxide that's in it.
Say, mister, keep your paws off me.
Don't be afraid. I've been waiting for you.
Oh, I heard about you. What do you want me to do?
You are going to help make food for this plant we are inside of.
What's this? I was light energy from the sun. This here, chloroplast. Trap me in those entering this plant cell.
I was water mixed with minerals. I was pulled out of the ground by roots and carried into the xylem, a tube and stem.
So let me get this straight. Sun through the top of the leaf is trapped by this here chloroplast. And water travels through an only tube called the xylem. That's right.
Say, how did you get here?
You might have to into the bathroom.
What do you mean?
Like the other side of the leaf?
Exactly. You see, there are many little openings on the underside of the leaf called the stomata. The rest of the guys are traveling, and there are a lot of other air molecules that came in with me. The rest of the guys are traveling through the rest of the plant to see where they can help.
That's right. Now, it's time for the water molecules to join hands with the carbon dioxide molecule. The combination should produce food, also known as sugar.
Say, if they're combining to make sugar, what do you need me for? You didn't just capture me so I can just watch, did you? Because I'm really very important. There's a lot of dark spaces to explore, a lot of gloomy people who need me to help cheer them up.
We need you very badly. In fact, water and carbon dioxide can't make sugar without you. You have light energy. You will supply the water and the carbon dioxide with the energy to make all this happen.
Okay, now you're talking. I'm cool. You can't do this without.
And you can't do it without us. Get over yourself and let's get serious. We're ready.
Okay, light energy, you stand behind the water and carbon dioxide. Ready, set, begin!
Whoa, we feel funny. Whoa!
Well, I'm glad to say it worked.
It worked all right, but who's this little guy hanging by us?
Oh, I almost forgot. This is oxygen. Whenever a plant makes food or sugar, it also makes oxygen. Now, when the sugar is sent to parts of the plant that need it, some oxygen will be sent with it. But we always seem to make more oxygen than we need. So a lot of oxygen will be extra and have to leave the plant.
Oh yes, well the oxygen leaves through the back door and out through the stomata.
Exactly. Now, it's time for you to be on your way, sugar.
Where am I being sent and how am I getting there?
You will go to wherever you are needed. Some of you will be used in the stem, and others will be used in the fruit part of the plant where you will become starch. And others will go to the roots so that they can get bigger.
Sent to the roots? Isn't that a long way down? What do we do? Parachute?
No, silly, you ride the flow. It's a tube like the xylem, except that it takes sugar to other places.
Okay, so now that we've become sugar, we need to ride the flow to wherever we need it.
Yes, indeed. Now, on your way, sugar. I've got to get busy. There's light energy coming my way, and I'm fixing to lay my trap.
Thank you. Thank you.
Remember when we talked about water leaving through the plant through its stomata? Well, cottonwood trees will lose about 100 gallons every hour on hot desert days. Each year, plants use more carbon in photosynthesis than is mined throughout the world.
1 million acres of corn can produce enough oxygen in 11 days to supply 10 million people with enough oxygen to breathe for a whole year.
If there was no more photosynthesis,
little food on Earth, most organisms would disappear, and in time there would be no more oxygen in our atmosphere.
1774, Joseph Priestley first documented the process of photosynthesis. That's 239 years ago.
The fossil fuels that we use today all have their origins in photosynthesis. Coal was formed around 370 million years ago. When large trees fell into smaller, the trees photosynthesized and made organic matter over millions of years. With high temperatures and with great pressures, the organic matter changed into coal.
When does 6 plus 6 equal 7? When you're talking photosynthesis. 6 molecules of water plus 6 molecules of carbon dioxide. And of course, light energy equals 1 molecule of sugar and 6 molecules of oxygen. Thank you for coming to our